we are going to model the reinforced concrete beam in ABAQUS. Before going to that, we have to learn what are the dimensions we have. So we have 2-meter beam. The length of the beam is 2 meter, and cross-sectional dimension of the beam is 260 plus 160 mm. Now here, if you see that we have reinforcement, that is a tie bar. Tie bar, the dimension of the tie bar is 6.5, and spacing is here 150 mm. We have main reinforcement, that is your 12 mm diameter bar, and we have 3 bar as the main reinforcement at the bottom, and we have 2 bar at the top, and diameter of the bar is 8.5, is 8 mm. Okay, now if you want to model the beam in ABAQUS, so we have to create 4 parts. Part 1 is corresponding to our 3D solid concrete beam. Second part 2 is a wire type of element representing our stirrup. Part 3 is the main bar, that is your 12 mm diameter bar, and part 4 is your top reinforcement, that is your 8 mm diameter bar. Okay, so now first we'll create the concrete beam, the part 1, okay, and we have to enter the cross-sectional dimension of the bar, okay, and then we can extrude it up to 2 meter. Then we can make the concrete beam. Next is that stirrup. You have to know what should be the dimension of the stirrup. Here, if you see that cross section here, this point here, this 0, point will come at 0, okay, and this stirrup point will come to this location, okay, and then position of this stirrup is your 18 plus coordinate of the stirrup is 18, 125. If you think of your XYZ 3D axis, you consider all the 3 axes in X, Y, and Z coordinate systems. If we consider the geometry in X, Y, and Z coordinate system, so this 0, point, this 0, point will come here, and the location will be your 18, 25. So 18, how it is 18? If you consider 15 mm clear cover and half of the diameter of the stirrup, then it will come 18 mm. So X also will be 18, Y also will be 18, and 25 is 25 mm cover. This 25 mm cover we are considering. Okay, so this is the location of the first stirrup, and first coordinate is 18, 18.25. So here you have to first create with this dimension 0, 0 and 124.224. That dimension you have to create, and you have to rotate and translate it, and you have to place in this position. We'll see how we can do that. So how 124? So 124, that means 124, that basically you can see here 160 minus 18 from this side and 18 from this side. So this will come as your 124. So you can imagine like that, like this. So 18 minus here, and from 18 here minus here, so we'll get 124. Similarly, we will get 224. Once you create the stirrup, with this dimension, in the assembly, you have to rotate and translate so that you can place it here. Okay. Next is here. So part 3, that is corresponding to main reinforcement, that is corresponding to main reinforcement. That is your 12 mm diameter bar, and we have 3 number of bar. Now again, we have to identify what should be the coordinate. What should be the coordinate? Okay, what should be coordinate in the XYZ coordinate? So here you just see first one. It is your first of all you have to create that First of all, you have to create the stirrup. Stirrup length of the stirrup will be 1950. So 1950, that means here 25 cover minus, and this side also you have to minus, you have to deduct 25 mm. So both the side, if you deduct 25 mm, it will come 1950 mm. So first you have to create a stirrup, or you can say a wire type element with a length of 1950. And next, in the assembly, you have to rotate and then translate, and you have to place in this position. So the coordinate of this position is 27, 27, 25. So 27, that means your 27 here, that is corresponding to your 15 mm cover. 27 is corresponding to 15 mm cover, 15 mm cover plus your 6 mm stirrup and half of the diameter of the main investment. And it will come 27 and 27 and 25 is that here for position considering the cover. So it will be 27, 27, 25, and this location will be in the middle of the beam, so it is 80. And again, this side you have to consider. Again, you have to deduct. You have to deduct 160 minus 27, so it will come 153. And this location will be 27, 25. Okay. Now, if we consider the top reinforcement, the location here, this again, it will be of your plus 6 mm diameter bar plus 4 mm. So it should be how much? It should be 21 and 25. It should be 25. It should be 25. 260 minus, it should be 25. It should be 25. 260 minus minus 4. And 6 stirrup, 4 is half of the diameter of the top reinforcement. Okay. Will be your 235. So it should be 25, not 27. It should be 25. Instead of 25. So here, what we are going to do? We are going to create the 4 part. So here we are creating part 1, that is corresponding to solid concrete beam. Here we will choose reinforce. Here we will choose. Here we will choose rectangular section. And first coordinate is 0, 0, and second coordinate is 160. And then here we will extrude it up to 1000 mm, that is 2 meter. Next, we are going to create the part 2. Part 2 is corresponding to wire element. And here again we choose rectangular, and again here we will pick the coordinate 0, 0, and second one is 1, 2, 4. Cross it down like that. You can create a stirrup. Next, part 3, we will create the main reinforcement at the bottom. We choose this option. Coordinate 0, 0, 9, 5, 0, 0. And fourth part, that is to top reinforcement. Again, here is the same 0, plus 4. Now, here if you see, we have created 4 part. Now, what are we going to do? We are going to assemble it. How we are going to assemble? We will go to the assembly module, and here we will create instances. Part 1, dependent mesh. part 2, 3, 2 as a dependent mesh because this is going to repeat. So we will create mesh once, create the mesh on the part, and it will automatically put the meshing for all the stirrup, for all the main reinforcement and the top reinforcement. Okay, so we have created the instances here. Now what we are going to do, we are going to place the reinforcement in their position. Okay, so first we are going to use your stirrup. Here we will translate the stirrup. So here we choose the instances, and part 2 is our stirrup. Okay, so choose it, and now here it is saying that select the start point to translate. So here we choose this point, and then it is asking the end point for the translation. So end point will be 18. 18. Here, if you do, we will check that we have translated the bar according to our calculation. Next, what we are going to do, we are going to translate and rotate the main reinforcement and the top reinforcement. So let us see how we are going to rotate and translate the main reinforcement and top reinforcement. Here, put the instances, then here we will put the rotation of your part 3, and here it is saying select the start point on the rotation. So the start point will be 0, 0, and it is asking select end point on the axis of rotation. So your axis of rotation will be y-axis. So here I'll put 1 here, 0, 1. So that is basically for y-axis. Now it is saying to which angle we want to rotate, angle of rotation. So here if you see, it is rotating in anti-clockwise. So here I will minus sign, so it will rotate clockwise. Okay. Now we have done the rotation. Now we will translate it. Translate it. We will translate the position, this position, okay, to our position of 27, 27, 25. This is the first. This is the position of the one corner reinforcement, that corner, one corner, that your bottom reinforcement, one main reinforcement. Okay, this is the position of the corner reinforcement at the bottom. Now we will again, no, 85 minus 27. So second instances will be 80 minus the distance of 27, 53. Second instance will be a distance of 53. Third instances will be create at a distance of 33 minus 50. 53. So third instance also will be create a distance of 53. So like that, we have created the stirrup, main reinforcement, and top reinforcement. Here, you see the 3D view, you can identify the bottom reinforcement, top reinforcement, and there is the one stirrup. So now what do we do? We have to create the number of stirrup. So again, what do we do? We have to go for instances, then we have to go for linear pattern, and we have to choose which second we want. And now we have to create instances. If we have to create offset, we have to create offset in the Z direction. So here you have to choose the Z direction. Here Z direction. Here you have to choose the direction here. This is the direction, and you have to define the length of the offset. So here we can create the offset, okay, at a distance of 150 m. So number of offset will be how much? Number of offset will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14. Here we have to create. Okay, now okay. Now if you see the location here, you can see that this is your top one is your concrete part, solid concrete part, and inside we have stirrup. So now here you can see that this stirrup is at, you can see this stirrup, location of the stirrup somehow stirrup looking away. You can see location of the stirrup away. So what we can do, we can check the coordinate. Here we can check the coordinate. This coordinate is your 117. 17. Okay, so we have to rotate it to this side. What we can do, we can see from this. Now, this coordinate 18, 24, 18, 18, 25. That is fine. 18, 18, 25, fine. Top reinforcement here. It's 7, 2, and 7. Why 7? It should be 27. Okay. Which is this side. 117, 217, 0. Would be 25, no? Okay, so what we can do, again, we can choose that. Choose that distance, choose that part, and we can translate it. We can translate it. We choose this one, choose this coordinate. Okay, end point should be your 5, 5, you know. And it's fine. Similarly, we have to have this element and coordinate will be coordinate will be your 135, 1, 5, there's nothing to worry if it is mistake. You can correct it here also. Now you can see correct way same. Okay. Now again we choose the. Now we'll check the. Now we'll check the. Now we'll check the position of the main reinforcement here. It is 9,9.9. Now it is 9. What we can do, we can use the main reinforcement. Now we can choose this location, and this would be 127, 125. Second distance is this one, and this coordinate we choose, and this point will be 18, 127. 7, 25. And again, we translate third one, this one, this location should be 0, 1. Now you can see we have done it correctly. Now you can see we have done it correctly here. This is fine. This is A and this also another corner. Now again we can check it. We can check this corner. Okay. 142, 18, 25. 142, 18, 25 is fine. And near about reinforcement location is 133, 27, 25. Okay, so it's fine. Okay, this reinforcement is corresponding to 80, 27, 20. Okay, so all locations are fine. Now we can choose this option. Now here you can see we have beam, we have 3D concrete beam along with the reinforcement. Now what I can do, we can go for meshing, we can define the property.